All right, action. Welcome to Yay Math. Good morning.
Good
morning.
Good morning.
Good morning.
Nice. Today we'll be doing congruent triangles. Thank you for joining. It's the day before Thanksgiving, so I'm feeling good. How are you guys feeling?
Awesome.
Awesome.
Nice. I was thinking about you guys yesterday, this particular group. I think it's been fun since we started school together. I really, really like you guys.
We like you.
I really,
really like you too.
I really do. I really do. It means a lot to me.
Got a lot of energy in here.
Yeah, I'm saying.
It's a loving holiday.
Thanks for the life. You know what I mean?
Thanks for the teachers.
Sure. Thanking your mom.
Peace.
Peace
Sign.
and love.
That was awesome.
Is this so obvious?
Oh no, that's Miss McCauley.
Peace and love. Peace and love.
It's like peace, love, and happiness.
Peace, love, and
I don't even know.
Peace, love, and happiness. All right, thank you for that. I feel even better. Okay, so question for you, and then answer back with the same question, but don't ask it as a question. Say it as an exclamation. Yay math!
Yay math!
Nice.
Yoy
Yoy
math.
math. Right. Gotta keep it real.
You have to make a weird noise.
Yoy?
Yeah, there you go.
Okay.
We're done.
We're doing more of congruent triangles. Notice there's two triangles congruent here, or excuse me, not congruent, but there's two triangles we want to prove congruent. However, there's an issue that we haven't gone over yet. Notice what we're trying to prove. Are we trying to prove that two triangles are congruent here?
No.
No.
No. All right, so new wrinkle. Yeah, wrinkle in the plot. So the wrinkle is, even though the prove statement says not to prove the triangle's congruent, we are going to prove the triangle's congruent, and then we can prove this congruent, and I'm going to explain that later. Okay, I'm going to explain that later. So before we continue, what are the four ways we will prove this?
So we're ignoring proofs.
No, don't ignore. Keep it alive. I'm just saying, let's pretend we're just going to prove the triangle's congruent. That's all I'm saying. What are the four ways we learn to prove triangles congruent? Yeah, what are two?
SAS and SSS.
Okay, so we have SSS, SAS, two more?
ASA and AAS.
ASA, AAS. And someone to explain what these are about, what do they mean? What's the idea behind them? Yes?
The sides and the angles,
The sides and the angles, right? And what about them?
where they're shown on the triangle.
Where they're shown to be what?
Congruent.
Yeah, did you say congruent? Yeah. Basically what it's saying is, for SAS, for example, you have two triangles. They each have two congruent sides, and they share one congruent angle. And if they have two congruent sides and one congruent angle between them, then the two triangles are congruent. So what do these do?
Show congruency.
They prove congruency, show triangles congruent. They're the four ways of proving triangles congruent. That's right. So even though this doesn't say prove triangles congruent, I'm going to ask you, let's just make the triangles congruent, and then I'll take it from there with you. All right? So here we have this triangle and this triangle, correct? We have parallel lines marked. We have DK bisects JE. Suggestions for how to prove this congruent to that. What part of this is congruent to what part of that? Let's do a few in the back, yeah.
You can do EG is congruent to GJ because definition of bisect.
Okay, cool. So you see that JE is bisected, the segment JE is bisected, here it is. And if it's bisected...
Oh, so then it's DG.
You're right, no, you're right.
Oh.
JE is bisected, correct?
Right.
So which one's cut in half?
JE.
JE. And so if JE is cut in half, that means that this is congruent to that. And how did you phrase it?
I said EG is congruent to GJ.
EJ.
Definition.
How about JG? So like kind of keep it outside to in, outside to in.
For definition of bisector.
Definition of bisector, yes.
Okay, so I don't really know how I'm going to use this, but if G is the midpoint of all of it, can't you also use that?
We're not doing
Okay, let's first finish this step. Are you comfortable with this step?
Oh, yeah.
Okay, so we're comfortable with this step. So we have an S done, correct? Here's an S.
I'm confused what we're doing.
We're trying to prove this triangle.
JK or no, it's a separate proof.
What, excuse me?
Prove DE equals JK.
I'm saying we will get here. We will get here. For now, all I'm saying is, first prove the triangle's congruent.
That was so.
That's okay. Okay, yes?
DE is congruent to JK.
DE is congruent to JK. Okay, I'm glad you said that. First of all, that's what we're trying to prove. Okay?
But
Secondly,
the parallel doesn't that make them automatically congruent?
if two lines are parallel, are they congruent?
No.
Not necessarily. So I'm glad you said it. Not necessarily. Two lines parallel doesn't mean they're congruent. And since there's nothing mentioned about whether DE is the same as JK, we can't assume it. That's kind of the magic behind the proof. All right? And kind of in life too. Don't assume anything unless you can absolutely prove it. Yes?
Can't you say that like angle E is equal to is congruent to angle J because they're both consecutive angles?
All right, you're on the right track. You're on the right track. So let's do, want to do parallel line stuff? Okay. Parallel line stuff, we got angle E is congruent to angle J. As far as parallel lines go, as in, let's replicate our parallel lines here and here.
Oh, it's alternate.
And then you have this,
It's
and we're talking about these, aren't we?
So they're
What are they called?
alternate interior.
Alternate interior. So, angle, do we need 3 letters for angle E, guys? Or can we use just angle E?
Just angle
We
E
can just use angle E. Why?
because it's only the angle.
This is the only one there. Angle E congruent to angle J.
Will you give an example when we could not use only
The one G. Something with G, because there's 4 angles, or 6 actually.
Oh,
There's
I
a lot
got
there.
what you're saying.
Okay, angle E congruent to angle J. Reason?
Alternate interior
Alternate interior
angles.
angles are
Congruent.
congruent. Correct. All right, good. So now, is that an A or an S?
A.
That's an A, correct? So we have 2 of them done. Next. Yes?
Oh, you can also do the other bisect when when TK bisects JE, doesn't it work the other way also?
Oh, you're saying that if DK bisects JE, does JE bisect DK? Is that your question?
Yeah.
No, because
No.
we don't know if DE
Oh,
is
yeah.
Not
the same.
necessarily, yeah. We can't assume that, not necessarily. So I'm glad you said that too.
So we can't assume that D and K are congruent?
Can we assume that angle D and angle K are congruent?
No. Oh
The
yeah.
angle D and
Yeah.
K.
Yeah.
Yeah,
Why?
that's the same
It's
as
the
the
given.
given.
What about the given? Angle D and angle
Because they're
K?
alternate interior again.
They are.
So we can make that the,
We can make that the next one,
Okay.
right? We could do another alternate interior. Or you guys, we can do,
Could you do angle G is equal to angle G?
okay, that's when we need 3 letters. We could do these 2 angles as well.
And could you say
D, J, E, and J, G, K. These 2 angles, what are they called?
vertical angle?
Vertical angles.
Vertical angles are always,
Equal.
yeah, it's congruent or equal, so we could do both. So what would you like to do?
The
Vertical angle.
Let's do vertical, because we already got one of the parallels. Let's do vertical, get practice. So that means we're implying that this angle is the same as the one across from it. Letters go, angle D, G, E, congruent. So if we start at D, G, E, where are we starting over here?
J.
J.
Let's start at K actually, because D is the same as K.
Alright.
So
Alright.
K,
So
J,
K, G, J.
KGJ.
K, I always have to go this slow for this. K, G,
J.
J, right. All right, reason?
vertical angles are.
Vertical angles are congruent, that's exactly right. Angles are congruent. Is that an S or an A?
A.
A, okay, now according to the picture, this triangle can be said congruent to this triangle now by which of these 4? Yes,
ASA.
ASA, correct. ASA, why ASA?
Because you're using the angle for the angle E and J.
Look at these 3, that's what I'm asking.
Right, because then it's an angle side
Right.
angle.
The S is between the 2 A's in the picture. The S is between the 2 A's. So we can say triangle now. Let's do D, G, E. Congruent to triangle K, G, J. Very good, you guys.
We didn't do the proof.
We didn't do the proof yet, this, the ASA. Now, new concept, gonna explain it for a second. New concept, okay? We didn't do the prove yet. Here's how this stuff operates. What we need to do, if whenever you have triangle proofs and you don't have a triangle in the actual prove line, you need to first prove the triangles are congruent. Because if you first prove the triangles are congruent, then you can prove any little piece about the triangle congruent.
Oh.
Right? Does that make sense? Think of it, I have an analogy is like with houses. If I prove that two houses on one block are exactly identical, I first
You
prove
can say
that.
the kitchens are identical.
I can say the kitchens are identical. That's the concept. Yeah.
Can you say that like if the kitchens are identical, but then the bedrooms are different?
But then they wouldn't be
Right,
identical.
right. If kitchens are identical, we wouldn't
But
be
why
able
do
to
they need
assume
be
any.
Identical houses? Like I'm not saying, like I'm saying,
Right.
like why does every part of the triangle have to be?
If every part of the triangle is congruent, then I can say little pieces of the triangle are congruent. That's the idea. So we just prove, and this analogy is kind of nifty, because this does look like a house in a way. So if the houses are congruent, then the bathrooms are congruent, all right? So what piece of the houses are we talking about here?
Parallel lines. DE.
DE and JK. So now that this triangle is completely exactly identical to this triangle, are we allowed to assume that this piece is the same as this piece?
Yes.
Oh,
Yeah, but what is the property?
And we're done. I'll tell you what the property is. First, let's write it. Yes.
Or I was gonna say what the property was because of definition of isosceles triangle.
Okay.
Wouldn't it be
It's not necessarily. No, this is not necessarily isosceles. This triangle's not.
Definition of congruent.
No, I like that you're guessing, but you'll never guess unless you read the book. Because it's funky. Here's how it goes. Do you agree that corresponding parts of triangles that are already congruent are congruent themselves?
Yeah.
Yeah.
Corresponding parts
Oh,
of congruent triangles are congruent. Learn it. Love it. Know it. Say it quick.
Corresponding.
CPC.
Say it quick.
I can't.
Who has a mnemonic for it, perhaps? How about
Carl
Carl
plays
plays
With
cockroach,
cello?
cello
Carl plays cello
to
to
Children.
children, to cats.
like
My name is Carl.
That's so cute.
Carl plays cello to cats. And they're like, what's wrong with that? And they start loving it, you know. Oh wait, this isn't cello, dude.
oh yeah, this is like a violin.
Yeah, I know. What's my problem?
Carl plays cello to
I'm
You
down.
know your instrument.
Carl plays cello to cats. You guys are.
Cats,
Or
okay.
Chase.
Corresponding
I like
parts
the
of
name
congruent.
Chase.
Carl plays cello to Chase.
Mhm.
Hey Chase, man, you gotta come over, man. I got the
Gotta
sick
play the
tune for
cello
you,
for
dude.
you.
It's like, dude, you have violin? I got the cello tonight, baby. He's like, "Ah, I love this song. He's like, I love your name, Chase. We changed it from cats. All right, good job. Okay, Carl plays cello. Next proof. Let's knock it out. Okay, so draw another table. You know, one of these. And then you see a picture there. I'm going to do that as well, so you can get ahead of me. All right, I will leave the 4 up. Okay. And I'll transfer. Hey, Carl.
That was actually like funny.
What's up, Carl? Okay. Any other instruments that start with C?
It's like that guy who plays the flute and all the mice come. Like
Charles.
cats from everywhere
Charles.
come.
We could play cat.
It's like, you're not Carl.
Chester.
I'm Charles. I'm Charles.
Chester.
I like Chester for like a doll.
What other instruments though?
Chester.
Yo, Chester. Come here.
Chester.
Listen, Chester.
Oh,
I
biscuit.
realize
Just
everyone's gonna hear this.
I always forget that it's recording.
Chad.
Chad.
I really should.
Like,
No, new
Turnus.
instruments, people. New instruments.
Chad.
New instruments. You guys are.
I was thinking of turnip.
Oh,
but then I thought that's not a word.
I play the
I
turnip.
don't know where you like.
It's like a turnip turned into a harmonica.
How did turnip turn into a
One day you have to bring a
harmonica?
harmonica. We should each have an instrument one day.
Oh wait, prove.
I want the
I'm so bad.
I want the cello.
No, I take the piano.
All right,
You bum.
back to biz. So, but thank you for that. That was great. Carl has always played the cello so well for his friends and for little kitties.
Both named Chase.
Yeah, the cat's named Chase.
Every single cat is
Chase,
named
come here.
Chase.
Chase, Chuck, and Chad.
That's they doing the thing.
No comment.
Boom, 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 boom.
Yeah, we don't really have cello in our arms, so they don't.
All right, let's prove now. Are we trying to prove that the triangles are congruent?
No.
Not
the
directly,
angle.
the angles, right? Not directly. We're not going to prove that these are congruent until we prove what?
The
triangle.
So good, good. Okay, let's prove the triangle is congruent then.
Okay.
What do you got? You got one? Go.
Okay, AB is congruent to CE because of midpoint, definition of midpoint.
Okay,
Or bisector.
so we see BD, the line, segment BD, excuse me here. BD bisects segment AC, so AC is cut in half. If AC is cut in half, indeed, these two are the same. Let's rock.
And roll.
AB, congruent to CB, def of bisector. This is not an angle bisector, it's a segment bisector. Because it's a segment, right? So is this A or S?
S.
S, done. Okay, 1/3 of the way there. Someone else? What about, yeah, hit it, loud.
DB is congruent to DB
Okay,
because it's reflexive.
right on. DB, up, yeah.
And I wrote it and then I erased it.
Don't erase.
What are you talking about?
She wrote it,
I wrote it wrong on the quiz.
Is this one from the quiz?
I wrote depth of midpoint
It's
for
like
that.
the one from the quiz.
reflexive property is when
What definition of
something's,
midpoint?
definition of midpoint is when you cut something into two equal parts, not when something's equal to itself. So is this an angle or a side?
Side.
It's a side, so here we have side here, that's a side.
I think it's E.
All right, yes,
DA is congruent to DC because of bisector.
okay, no, not necessarily, not necessarily. We wouldn't be able to say that DA is congruent to BC, because what's being bisected? AC is being bisected, right? It's a good guess. What do you have? Yes?
Angle ADB is congruent to angle CDB because definition of angle bisector.
Okay, so let's look at it. Let's look at it. Many times in my classes, I hope for my students to use the given statements more. We use this one.
It's like easy giveaway, kind of. Like you
Yeah,
understand it.
the given's supposed to help you get it done. So BD is bisecting AC, so we analyze. Oh, AC is cut in half. There
The
it is.
given is supposed to give.
Now BD bisects angle ADC. Yes?
Can you say AD equals DC?
No, we can't say that
But
AD
then it
is
would
the
be
same as DC.
ASS. That would know.
Good,
Well, that's
good. Hold the thought. I know.
Ooh, which it can't.
I know.
Angle
That's
ADB
what
is
code is.
Yeah,
Angle
ADB.
CDB.
Yeah,
Not a
there's
problem.
not, AD is not mentioned, nor is DC. But angle ADC is. Angle ADC is being bisected, so this angle is being bisected, you guys,
Oh, it
right?
does,
Cut
but
in
it's
half.
equal.
So it's cut in half to this angle and
Definition of
that.
midpoint.
definition of angle bisector.
Angle ADB congruent to angle what?
CDB.
Oh, so then
Definition of,
angle
Bisector.
bisector.
right, we could do bisector. How about definition of angle bisector?
So, oh,
And then
Okay, so is that an A or an S? This is an
but the
A.
midpoint is dividing it.
Okay, now, do we have enough to prove these two triangles congruent?
Yeah, but we don't.
But what letters do they, what format is this?
AS.
Right, ASS or, ASS is back. SAA, right? Excuse me. SSA, let's see that, that's.
So then it can't be.
So far, we would have to say that this cannot be proven. All right, so far we'd have to say that. Yes?
But couldn't you like use information you have to like prove that AB is equal to CB? Couldn't you do that?
We don't have enough for that.
You couldn't say that like because AB and CB are
No.
equal and BD are not.
No, you know why? Because I can make a triangle I can make something that's not congruent here. Want to see? this angle, yeah, Todd?
Yeah, because like okay, you're gonna make angle B.
You said
You're gonna make angle B congruent at the angle. So like A, B, D, and C, B,
Go ahead.
D,
A,
and then it's
B,
B,
D,
S,
oh.
A, S.
Right, but we don't know anything about these.
Yeah, we do because the two lines that are being used are congruent. Oh, that's
That doesn't matter. Here, check it out. I can draw a triangle with these two angles the same. This line coming down to the middle of this, and these two the same as well. And they're not congruent. So SAA is not enough. Excuse me, SSA. SSA, all right? So far, the answer to this would be cannot be proven. However, let's just add. Let's add to the given here. Imagine, like some people said, AD is the same as CD. Let's say that this is also given, right? We're allowed to use givens later. Okay? So this is a good example. It gives you one that cannot be proven. So we did. SSA cannot be proven because it's not here. But imagine changing the problem that we include a new given statement, as in this is the same as that.
But we added given C.
Pretend it was a new problem in which there is more given.
We're allowed to do that.
So we
No,
do another one?
I'm
No,
just
that's what we're
saying.
doing now.
I'm just saying, pretend it's a new problem in which this is now given as well. Because the previous one cannot be proven. All right, that was the answer. Cannot be proven. Okay, so now if AD is the same as CD, do we have enough to prove that the triangles are congruent?
Yeah.
Yeah.
Okay, by what law do you want to use?
Side.
Side works. What else would work in this case?
SAS.
SAS would work as well. Do you see it? Is anyone better than the other?
No.
No.
No. Okay.
Of course not.
Of course not. So let's do triangle. We can do this convention. ADB congruent to triangle CDB. Let's go with SSS because it's the OG.
Wait, I don't understand.
What's
How
up?
can you just put that there? There's nothing that proves it.
Proves what?
AB congruent to CD.
Oh, I'm saying pretend it gave it to you. Pretend it was given. I changed the problem to include it as the given. So you look at it in the book or whatever. It says, oh, okay, there's 3 given statements. 1, 2,
So we can prove it.
and 3. Now we can prove it, right? So actually, you spotted the fact that it was SSA.
Yeah.
That's good. So it cannot be proven with SSA. So now, new problem with this new given, it can be proven with SSS. Are we done?
No.
No, we're not done. We didn't prove this yet. But we're one step away, aren't we?
Mm-hmm.
Can we say this now?
Yeah.
Yeah.
We can say this now. Do you understand why we can say this now? Okay. So let's say this now. Angle A congruent to angle C. What is Carl about? What's Carl doing?
Carl
Plays
plays.
cello.
Carl plays cello.
Cello.
Two
cats.
cats.
2.
I'm gonna
Cats.
have that.
Chase.
Okay.
Charles.
Now, here's the question. Who remembers what it stands for real?
I do.
Remembers what
I
it
never
stands for
knew.
real?
I did.
Let's try. No, remembers!
Oh, never mind.
Don't look at your notes. Okay, we go.
Corresponding parts in a congruent triangle make them corresponding.
Oh, so close.
Congruent.
Yes.
Corresponding parts of congruent triangles are congruent.
Corresponding parts of congruent triangles are congruent also. Who else wants to try? Do it. Yes.
Corresponding parts of congruent triangles are congruent.
Corresponding parts of congruent triangles are congruent. Who else wants to try? Who else wants to try? You want to try? No? That's the spirit. You want to try?
Is it corresponding parts of congruent triangles or corresponding?
No, are congruent. You want to try again?
Corresponding parts of congruent triangles are congruent.
Yes. Corresponding parts of triangles that are already congruent are congruent themselves. Okay. I'm satisfied. Are you?
Yeah.
Yeah.
I so am.
Just say CTCTC best.
And
Not yet. That was funny. Who could say, everyone say, this will be funny, everyone say CPCTC 3 times fast. Ready, go. Feels like I'm being attacked by bees. Ah! I'm trying to play the cello. Bye.
Bye.